Hi everybody and welcome. In this tutorial, I will provide an introduction to the expanded world of optimization, and I will show you how to model and solve optimization problems using the GAMS modeling system from the very beginner level to the advanced. So, as some of you know, GAMS stands for General Algebraic Modeling, and it is a high-level modeling system for mathematical optimization. GAMS is designed for modeling and solving linear, nonlinear, and mixed integer optimization problems, which I will explain you what they are during this tutorial and my next tutorials. So let's first start GAMS. So this is how the GAMS environment looks like. In order to get started, I'm going to create a new project. From the top of the page, click on File and click on New to create a new project. So this is the environment that we will write our codes, and we will run the GAMS optimization by clicking on this button. So before getting started, let me provide you some information about what optimization is and what components is optimization made of. For this purpose, I have provided a PowerPoint file, and as you can see, let's take a look at optimization definition. Optimization is in mathematics and research, optimization is the selection of an element or elements with regard to some criterion in order to achieve an objective. As you can see from this definition, each optimization problem has three aspects, three components. So the first component in every optimization problem is the variables. Variables are the elements that we need to find their values in a way that they meet a certain criterion. So this certain criterion is called problem constraints in optimization, and we need to find the variable values in a way that they minimize or maximize an objective. So the objective is called an objective function in the optimization problem. And so objective function is a mathematical expression that we need to minimize or maximize it based on our needs. In order to get started, I have provided a very simple example. It is a very simple optimization example that we will first explain it here, and we will try to solve it in the GAMS, and after that we will analyze our results. So here is the problem. Consider a hypothetical country called Republica, which produces only two products: agricultural, which is denoted by X1, and machinery, which is denoted by X2. Assume that three primary inputs are available: labor, energy, and capital. And to produce 1 unit of X1 and X2, the following inputs are required. So the relation between input and output is shown here. Suppose both units of X1 and X2 have the same value. Planners in Republica wish to maximize total output in the economy. Suppose also that total supply of labor is 20, of capital is 15, and of energy is 10 units. What is the optimum combination of production in Republica? Let's first find the three most important components of this optimization problem. As you may have already understood, our objective function in this problem is to maximize x1 plus x2, and our constraints are defined as follows. These constraints are obtained by the fact that total supply of labor shouldn't be more than 20, of capital shouldn't be more than 15, and of energy shouldn't be more than 10 units. So we have multiplied x1 and x2 with the amount of labor, capital, and energy that each of them need, and the they shouldn't be more than the amount of labor that we need shouldn't be more than 20, of capital shouldn't be more than 15, and of energy shouldn't be more than 10 units. And our variables are x1 and x2, so we call variables in a optimization problem as decision variables too. I have provided a graph for this optimization problem. This is shown in the next page. Imagine that y-axis shows x1 values and the x-axis show x2 values. Here I have drawn my constraints as functions, and I have just provided the area that meets all the constraints, and I have named it feasible space. So this is not a name that I have provided, so this is a name that is used in optimization problems. So feasible space is the region that we can choose our variables from, and if we choose our variables from this region, they will meet all of our constraints. As you can see, the capital constraint has no role in defining the feasible space because it doesn't force any new constraints, and our feasible space is already a way smaller than the area that is defined by this constraint. So the constraint that has no role in defining our feasible space is called as a redundant constraint. So in every optimization problem, we need to choose our variable values from this feasible space. If our feasible space area is equal to 0 in an optimization problem, this means that our optimization problem is not feasible. And if we just model this in this kind of optimization problem in any optimization system and software, we will get the message that your problem is infeasible. So, and our solutions are infeasible. Also, in the below figure, I have drawn the objective function in this figure as well, and as you can see, the intersection of all three lines defines our optimum solution. So in this problem, our optimum solution is this part. So let's go back to the GAMS and see how should we model this problem. I'm gonna start GAMS here, and So you should note that in every code that you write in the GAMS, we can define our variables as different kind of variables. For example, we can define them as positive variables, we can define them as binary variables, or we can define them as continuous variables. Also, in parameters, we can define our parameters as just parameters or scalars. So there is a difference between scalar and parameter, and you will see this difference as we start programming, and I will show you their difference when we uh, face these problems. So let's first define our variables and scalars. I'm gonna first start with scalars. So I'm gonna write scalar, and what are our scalars? So scalars are the uh, things that we know their values. For example, in this problem, we know the value of maximum number of labor. We know the value of maximum number of capital and maximum amount of energy. So I'm gonna define them as max labor, max capital, and max energy here. So first write the name max capital, and then write its values inside two backslashes. What was the maximum value? 15. Same for the others. And let's write their values. So at the end, you need to put a semicolon. If you don't put this, you will get an error. So in the next step, I'm gonna define my variables, and I'm gonna define them as positive variables. So here in this optimization problem, we only have two variables, x1 and x2, and because they are output of something, they cannot be negative. We don't have negative output in real world, so x1 and x2 should both be positive values, and here in GAMS we can define them as positive variables. This means that they cannot be negative, so I'm gonna define them right here. And in the same way, we don't know their values, so at the end we are gonna put a semicolon as well. And now we are going to define another variable. So this variable that I'm going to define, I will use it for the objective function. Imagine that in this problem, I'm just going to define s. So I'm gonna write variables, and it is only s. You may wonder that why I didn't define s as a positive variable. This is because in the optimization problem, the objective function cannot be set any constraints on. If you just define your objective function as a positive variable, you will get an error. So we cannot tell the program that our objective function is a positive variable. If and This is just gonna give you an error if you define it as positive variable. And our objective function should be a free variable. In the next line, I'm going to define my constraints. So in order to define constraints, we are going to write equation, and in the next line we are going to write equation names. So how many equations and constraints do I have? You may say that I only have 3 constraints, so I will have 3 equations as well. But you shouldn't forget the objective function as well. So this is our objective function is equal to x1 plus x2, and we need to define this as well. So in the GAMS, we need to provide a name for each of our equations, and I'm gonna name them. Let's first define the objective function. I'm gonna name it objective. I'm gonna name the second equation, which is this constraint, as labor constraint. So let's just write them all. Labor. And the next one as capital constraint, energy constraint, and yes, that's all. And we are gonna need to put a semicolon here as well. Next, we are going to define our equations. So let's start with the objective function here. In order to define equations in the GAMS software, you're gonna need to write the name of the equation, put 2 dots here, and write your equation after that. So my equation for objective function is that s equals x1 plus x2, and you need to provide a semicolon at the end of all equations. Here you need to put a semicolon at the end of each equation. If you don't provide it, you will get an error. So you should know that in order to show equal in the GAMS, you need to put 3 equal signs at both sides of an E letter. So keep this in mind, and I will show you how to show other types of mathematical relations in GAMS too. Our next constraint is labor constraint, and we are gonna write it here. Put 2 dots and define it. So I haven't written the coefficients here in these constraints as separate scalars. You could define these as scalars too, but in order to simplify our problem and our programming, I decided to not define them as separate scalars and just define them inside the programming. If you want to write a very user-friendly program, remember that you will need to define them as separate scalars. This is because imagine that you write a very long programming code, and at the end you decide to change some values of coefficients and things like that. So here it will be a lot easier to change the value of scalars, and you will only need to look for them inside the scalars, then look for them inside very long equations. So try to write them as different scalars in your own programmings. Let's see the capital constraint. Oh no, we are going to write labor constraint first. What was the labor constraint? 8 units of x1 plus 5 units of x2 should be less or equal to maximum labor, and we need to write it here. And remember to put the semicolon at the end. So let's write the capital constraint, and what was our capital constraint? 2 units of x1 plus 2 units of x2 should be equal or lower than 15. As you can see, in order to define the equal or lower sign, we will need to provide two equal signs at the both sides of an L letter. And let's define our third constraint, which is the energy constraint, and it is defined by 2 points of x1 plus 4 units of 2 units of x1 plus 4 units of x2 should be equal to or lower than 10. Why did I write them as letters? We already have them here, so I just made a mistake. Let's correct it. Max capital and max energy. Yes, and that's all with our constraints. So let's move on to the next part. So the last part in GAMS coding is to provide a name for our model. I'm gonna just name it x1 ex1 because this is our first example in this tutorial. So we are gonna write model ex1 two backslashes O, and now we are gonna tell the program that how it should solve this problem and what kind of problem is that. So remember that we told at the beginning of this tutorial that GAMS solves different types of optimization problems. So we have linear optimization problems, nonlinear optimization problems, and mixed integer optimization problems. So this one that we have written the code here is a linear programming problem. So this is linear because we have no nonlinear equations and formulations in any part of our problem and our coding. So all my constraints are linear, they're all linear functions, and my objective function is linear as well. So all my components are linear functions, and this is a linear optimization problem. I will tell you what nonlinear and mixed integer optimization problems are in my next tutorials. So I'm just going to tell the program that tell GAMS that this is a linear model, and it needs to be solved by linear solvers. So I'm going to write solve, sorry, ex1 solve ex1 using LP. So LP stands here for linear programming, and so we need to define if our optimization problem is a minimization or a maximization problem, which means that if we need to minimize or maximize the objective function. So as you saw in this problem, we want to maximize our production, so we should maximize the objective function, and we are going to write maximizing our objective function, which is s. Um, so I want you to know that GAMS is not case sensitive. For example, there are some softwares that and programming languages that are case sensitive. This is, for example, like MATLAB. But in case of GAMS, GAMS is not a case-sensitive programming language. So it's not a programming language, actually. It's a modeling system. So it's not case-sensitive. And we are gonna put semicolons here. You also need to put semicolon here. And yeah, that's all. And at the end, we can ask GAMS to display some of our variables. For example, here I wanted to display x1 and x2 for me. So if you want to display variables, you need to put a .l at the end of their names in the display part. So we're gonna write them like this, and put a semicolon here as well. And yeah, that's it, and we can run our code to see how it works. So in order to run, you're gonna click on the red button over here, and yes, you can see that it was run. So you're gonna get two windows here, and let's see what is the smaller one. So this window provides a description of how your code was run, and as you can see, it's at the first line, it says that this one was started, and in the next lines you will see more explanations. We don't need this for now. The thing that is important here is um, these blue lines, which means that our um, program, our code was run successfully. And let's go. And these blue lines are important. And the most important one is the status part, which says normal completion, and this line LP status, or this line as well, which says that optimal solution was found. So you can see our objective function value here too. And yeah, you're just gonna pay attention to these few lines here, especially this line, which says optimal solution was found, because we want the optimal solution here. And so let's close this window and go on to the next window. In this window, we will find more definition of how our code was run and different parts of our code and solution. You can see that all the equations are written here as well. And if you think a part of your problem was wrong, or you wrote it wrong by mistake, you can check it from here as well. And let's go to the bottom. Yes, here solve summary. This is also a very important part. I usually just check it from here. As you can see, it's written solution report. So the first thing you need to do is to check this part to see if if optimal solution was found for your problem or not. So as you can see, optimal solution was found for this problem, and we expected that because we didn't write any equations wrong, and our optimization was a linear optimization. So in linear optimizations, if you write all your codes right, so you will definitely find the optimal solution. But in nonlinear optimization problems, the value that you find may not be the global optimum, and it may be only a local optimum. But in case of linear programs, the optimal solution that you find is the global optimal solution. So I will explain you this in more detail in my next tutorials. Let's go to the bottom. From this part, you can check your solution variables. So in this problem, we have three variables: x1, x2, and s. So the value of x1 is 1.364, and the value of x2 and s are written in the next lines. You're just going to omit these lines, and only this part shows the value of your variables, so keep this in mind. Also, we ask the GAMS to show the values of x1 and x2 by using the display function that we used at the end. So as you can see in the display part, you can find the values for x1 and x2. So imagine that in a optimization problem we have many variables and we just want to see the values of some selective variables, and by doing so you can just easily find them from display part here, and you don't need to look for them inside the solver part. Also, I forgot to mention, in the solution part you can see the value of your objective function. As you can see, objective value is 3.1818, and this is the maximum value that we can get for our objective function while it meets our constraints. And this is the global solution, global optimum solution. And so we defined all our parts. Let's go back to the code. As you can remember, I told you in a at first that in our problem here, capital constraint was a redundant constraint. It means that if we just omit this constraint, it should have no effect on the value of our variables and our solution. So let's check this. Let's just see if omitting it will have any effect or not. So I'm just gonna comment the capital constraint, and for commenting in GAMS we use a star mark. So let's comment its equation as well here and run the program again and check our objective function and variables. As you can see, objective function is the same. Let's also check our variables x1 and x2. As you can see, they are also the same. So as you can see, this constraint was a redundant constraint, and by omitting that, we had no difference, no change in our solution. And yeah, that's all. So let's also see here, if you want to save this code, so this code is actually automatically saved when you press the run button here, but it is saved in its default directory in the GAMS directory. So if you want to save it in a different place, you're gonna save it as, and provide your desired name here. I'm gonna just save it here and name it as ex1, and you can see the name is changed here. So that's all for this tutorial, and I hope you learned a lot from this tutorial. In my next tutorials, I will solve a more complicated optimization problem using the GAMS software. Also, I need to mention that I have provided all these files with the tutorial and you can check them. And that's all for today, so I hope you enjoyed. Goodbye.